Is now time for our first discussion on the show. Now, conspiracy theories and controversies associated with genetically modified organisms or GM foods are still raging, even when scientists discovered GM foods to be safe. Nigerian government recently gave approval for commercial use of genetically engineered maize to enhance production. This is in addition to cowpea that was granted approval much earlier. This new maize variety is said to be resistant to drought and pests with increased yield for farmers. In countries like Turkey, GM food are considered suspicious and meant to reduce its population size. Elsewhere, there are even lawsuits against toxic effect of BT maize, but plans are being made to increase the supply of the seed for the next season. To discuss the benefits, safety or otherwise of GMOs, we have in the studio Dr. Rose Gidado, Country Coordinator, Open Forum on Agriculture Biotechnology. Welcome to the show.
Good morning.
Thank you. Good morning.
All right, so let's start with this because I'm sure a lot of viewers have no idea what a GM foods are. What is genetic modification of crops and how is it done?
Okay, genetic modification of a crop is the use of science, of course, science, technology to modify or to improve or to enhance. It's actually meant for improvement, enhancement, addition of value. It has to do with the DNA. The DNA, a DNA from another species of plants or from, an organism. Organism could be plants, it could be animal, it could be microorganism. So a DNA has actually been brought in. The DNA will be for a trait, that you want. If you want your plant, of course, to be drought tolerant or to be insect resistant, depending on the prevailing circumstance, depending on the challenge of that particular crop, you want it to be either resistant to pests, insects, or to be able to tolerate high temperature, So you take a gene, from an unrelated species and then incorporate it into what you want to improve. An example is the maize that has been deregulated a week ago. Okay, that maize has two traits. One trait is drought, the other trait is insect resistant. So it's even resistant to fall armyworm. And so it's like you have enhanced it or you have improved it. You've brought in this DNA material that has that trait, that has the gene. We're all controlled by genes as humans, either plants or whatever. How you look like, every of our things, we have thousands of them in our bodies. And every gene has its own function. I know that the gene is contained inside the DNA. So it's an advanced knowledge of science, just to be able to solve our own problems. We know that with the global warming, we have so many challenges facing us, high temperatures, and then drought, flood, too much rain or too little. So if we don't think out of the box, if we don't go out of the way, to improve these crops, we'll continue to have a food scarcity, a low productivities, our soil, no longer, arable, most of them, and then the little one land we have, there's urbanization. People are building houses every day. People are also cultivating. People are also industrializing, building companies and what. And so there's a lot of greenhouse gas emission. Greenhouse gas emission is those gases, that trap, the carbon dioxide and all those nitrous oxide and all those things. Once you have a lot of them, they get trapped in the atmosphere. So the atmosphere gets heated up, and once there is high temperature, so many things, don't fall into place. Imagine insects because of the warm weather and all those things, and then it also affects other activities of ours and all those things. So it's difficult for some seeds to germinate at high temperatures. So a lot of things are in disarray because of human activities. The population is on the increase. And so, with all these challenges now coming into play, if we don't go out of the way, out of the conventional technology, not that the conventional farming is not good, but there are challenges that conventional breeding cannot solve.
Okay.
So that's why going down the molecular way is actually the best. So if we go down that molecular way, of course, it's helping in addressing some of the challenges.
Okay.
And it's not as if we're abandoning the traditional way of doing things. We are not. You can't even complete the cycle of that genetic modification without even bringing in the traditional breeding. So they are like complementary to each other. So genetic modification is actually enhancement or improvement of your crop or what, by bringing in a DNA that has a trait that you want from another plant.
So
that is not related to that, maybe from sorghum to maize, something like that.
Okay, so
going out of the
you have been campaigning for the use of GMOs in Nigeria and beyond.
Yes.
Now, cowpea is the first GMOs approved in the country. What distinguishes
food crop?
Yes, that was approved in the
Not
country.
the first
Okay.
GMO.
So what distinguishes GMOs and others, and are they safe?
Okay, what distinguishes them is that gene of insert that you have brought into your crop. That is what distinguishes it from the conventional counterpart from other crops. That one, the genetically modified, has a foreign DNA in it, and that foreign DNA is to deliver a trait that you want, a desirable trait that will protect your crop from those challenges, either from drought, either from flood, either from insect infestation, either from a herbicide spray and all those things. So it depending on what, or either from salinity in case of rice. So that is what distinguishes it. So now they are safe. Why am I saying they are safe? They are safe because they are highly regulated. Is the most scrutinized technology in the history of mankind. Highly scrutinized, highly regulated. They go through a lot of testing, scrutiny. It takes you 10 to 13 years, sometimes 15, depending on what you're doing, for you to come out with a genetically modified crop or food that is safe for human consumption. It's because you're bringing, it's a deliberate, attempt. You're bringing in a foreign DNA just for improvement. Okay, so now bringing it in, I have to ensure that the DNA I brought in, is efficacious, is delivering what I want. It has been taken in the new plant, host plant, yes. Then I have to test for its efficacy. I have, like the maize that was developed, it was brought and then tested. If you plant it, then you like infest that maize, because I have developed it to resist fall armyworm or stem borer. I will now bring the larvae of those insects and then infest, put on the maize. So, and then now watch out if that resistance is there. So once I confirm that resistance is there, it's still, the larva does not affect the maize at all. Then I have now done my proof of concept. So after that, the next level, because once it's there and I've done my proof of concept, it means that that DNA is there and it's working. Okay, if it's working now, the next step is it safe to the environment? So I will also subject it to different, scrutiny. At the end of the day, if I harvest the seeds, or the grains that come up from that plant that has been modified, I will now still go to the lab, carry out safety evaluations, are there any other things, are there toxins in it? I'll have to feed those things to rats. The way drugs are developed is the same procedures. There's no difference. I have to feed, take to the lab, feed it to rats, maybe rabbits, animals, and check, open them up. Has it affected the liver? Has it affected this? Has it done that? All those things. So I have to carry out, and then at the end, I also have to carry out analysis of the presence of the nutrients, the macronutrients, the protein content, the carbohydrate content, the fat content, the minerals content. Is it the same? Because it's a comparative analysis. As I'm analyzing the modified, the non-modified version of the same species of crop, they have to go side by side. Yes. So if there is significant difference in the results, I have to stop it. It won't just go anywhere. I have to go back to the drawing board, because there shouldn't be significant difference. The only difference is that gene of insert. Is it doing its work? That's all. But if it affects the nutritional content, forget it. So, so it takes you have to do those things painstakingly, because it's something that it's human beings that will consume at the end of the day. And I, as a scientist, I'm also part of the consumers.
Right.
So it's something that I have to be careful, about. So scientists are very responsible people. You have to think for others that are not in the same class with you. Think for others, think for yourself, and all those things. So, once all those, because there are laid down standards, regulatory standards, which I have to comply to, and which the results have to fall within those standards. If they're not within those standards, forget it. So I have to ensure that everything goes well. And we have our international regulatory agencies, WHO, the FAO, the World Codex Alimentarius, the OECD. They are actually the ones that develop those standards, and those standards are being reviewed from time to time, depending on and they're being improved upon time to time. So it's not like a one-person thing. I mean, it's so many factors that come into play, combination of factors, so many regulatory agencies like EFSA, the European Food Safety Authority in Europe, and what every country has our own. And Nigeria, we have our own. We have the National Biosafety Management Agency, NBMA, that is saddled with the responsibility of ensuring that in Nigeria, whatever the scientists are doing, the breeders are doing in developing the GM crops, they do it within the standards, and they send their teams to monitor, all the time, a risk evaluation, risk management. If there's any risk, you have to manage it. If there's no risk, but continuous, there's no stop, So these efforts, combined efforts, like are actually to ensure that everything goes well, and then to repose confidence in people that yes, these foods are actually safe, and these are the procedures, the processes that are being followed, the evaluation process that are being followed, and all those things. So with that, at least we are comfortable. And with the deregulation now of the telomers, that was done a week ago, there was a dossier data generated from those efficacy tests, from those evaluations that were done, at the Institute for Agricultural Research. They put up those data together. And while they were doing it, NBMA was actually sending its staff, her staff to go and be monitoring all the time. So this data put together, of course, and then sent to NBMA. NBMA has a ad hoc committee, National Biosafety Committee. And the committee is made up of experts, of course, from all over, not just like NBMA staff, but they're being drawn from research institutes, from the universities and what. So they put them together and they look at the data. And you have to go back to the history of safe use of that gene you have used in the maize. Has it been used elsewhere? And are there issues? Did issues arise? And all those things. So it's a whole lot of research. It's not like an ordinary thing. So this is, with all this that I've given you, you should be rest assured that any genetically modified crop or food in Nigeria that has been approved, you should just know that it's safe.
Okay.
Because government cannot kill how people does it.
Okay, I think with your explanation, I understand better what it is all about, because a lot of people seem to think when they hear genetically modified,
Yes.
they think it's made from scratch in the lab.
Yes.
So that's where the skepticism comes from. But then, do the benefits of these kind of crops outweigh the disadvantages?
Yeah, of course, the benefits outweigh, like the soybeans. I mean, not the soybeans. Yeah, soybeans is in the pipeline.
Okay.
The beans that we have is the yield is 6 times the local variety. The local variety gives you maybe, can I say 350 kg or what? But the modified version gives you 2.9 to 3 tons per hectare.
That's huge.
So that's huge. That's one big benefit. And you know that yield is the aim thing in farming. Harvestable yield, strong yield is what every farmer yearns for. Because you have put in money. Without yield, you can't recoup what you have put in.
Right.
And in Nigeria, most of them are peasant farmers and what, because, I mean, their yields are usually low, and then they actually don't have the resources to go into large-scale farming. They don't have the facilities, tractors and all those things to really make it a big business. So the small one, I mean, land maybe they have access to, and the small grains that they have saved, they usually use their safe grains, and those safe grains do not give them any yield, and then they are not quality, because agriculture starts from the seeds. If your seed is good, you don't even have to use a lot of farm inputs. So farm inputs actually, makes it very expensive, very cumbersome. You have to do a lot of sprays. Like for the beans, you have to do like 8 sprays. But with this, yes, genetically modified beans, that already value has been added to the seed. So when you plant, you have 100% germination rates, and then insects do not, those insects that the crop has been developed to resist, they don't even come. You hardly see them on the farm. They get repelled. And so your number of sprays now will only be 2. And the 2 or 3, it will be those insects that the crop was not developed to resist.
So,
So from 8 sprays down to 2. So you can see that the benefits is quite, you are reducing costs. And then those chemicals, they pollute the environment as well. They degrade, and then they form nitrous oxide and all those. So I mean, and then your fertilizer too, you don't have to put so much. So that reduces production cost. Why our grains are very expensive, the farmer has to spend a lot. You know how much a bag of fertilizer is? I mean, sometimes up to 15,000 here in Abuja, you know. So it's not an easy thing. After putting in so much, you have to recoup, you have to get back your money. And so that's why the price go high. And most of the industry, the agro-industry, they prefer to import maize and what for their poultry. And they will tell you that it's cheaper to import. And why is it cheaper? Because those people out there in Argentina and Brazil, mostly the imported grains are from Argentina and Brazil. And most grains in Brazil are genetically modified. So there's no so much use of farm inputs, and so if the production cost is low, you can't, your price gets stabilized, prices go down, and then there's available food, you know. So if you have food available, scarcity goes off and prices get stabilized. So the advantages are so much. And then you're also reducing the greenhouse gas emission because you are not spraying so many, chemicals many times and all those things. So there's carbon sequestration, there's what. So the advantages are really, really many. And then because the seed is an improved seed, it's a quality seed. You know, once you plant it, like I told you before, you have 100% germination rate. You're not going to spray so much. You're not going to do, you know, so a lot of things. So on a small piece of land, like this place now, if you plant your beans here, you're going to harvest bountifully. Bountifully. We have a farmer, a young farmer in Kano, is being empowered by this. He said he planted, his name is Kali, he planted same amount of, you know, the local beans and but he harvested 24 modules from the genetically modified. The other one gave him like 4 modules or so. So, I mean, the difference is so much. So this young man now is into the genetically modified beans cultivation. And I'm telling you, maybe in few years, I'm sure he will become more empowered. And there are many other testimonies from other farmers that have planted the beans and also the cotton. We have 2 crops. Cotton was actually approved first, but cotton is not a food crop, it's a non-food crop. Even though directly or indirectly is also a food crop because the seeds are used for oil, you know, oil production. So the cowpea and the cotton, we have so many testimonies coming from farmers, especially this year. Many more farmers have planted cotton and they're all happy. It means I'm hearing they're excited, they're happy. Last year I visited many cotton farms in my state, especially Adamawa State. It was, I mean, so exciting. I was so happy. And the quality of the leaves, you know, superior quality. That is what they get, very white. Very, I mean, international standard. So in this, we can actually export our beans without problem. We can also, because there's no much residual chemical, you've reduced the number of sprays, and so you have so much. So you can export. Nigeria can be, you know, a global player in this, and we're already leading in Africa because now we have 3 crops all approved. You know, the teller means that has now been deregulated. The deregulation means that that gene of insert is safe and can be used, and farmers can have access to it. So the next line of action is to establish demonstration plots on farmers' fields all over the nation. Let farmers experience. They are practical people. A farmer would not take what you've given him unless he sees it.
Exactly.
Yeah, he experiences it. So they'll be given the seeds, of course, free. Carry out demonstration plot, and as they planted the modified version, they will also plant the local varieties side by side, and they will see the differences. That is how it works.
Okay, now talking about costs. Some would say, well, GMOs will be more expensive in the market than the local varieties as well. Is that so?
I don't think so. Like for the beans, the seeds of the beans, the modified beans, is 1,000 per kg, while the seeds of the local is 900 naira.
Okay.
1,000 naira per kg, then the other 900 naira. So a difference of 100. So I don't think when it gets to the market, I mean the grains get to the market, I don't think there will be much difference. I don't think so.
Okay, but how do you explain to people, because a lot of people seem to think it is unnatural?
It's not unnatural. It's a natural process actually, but the act of
transferring
DNA. That, yes, you're doing it. You're not putting them side by side. You're doing it is a deliberate attempt, and is to break that barrier. I don't want to go into science. Crosses, gene exchange of genes had been taking place in plants and all those things. You're putting it in the soil, it's interacting with so many things in the soil, you don't even know what it is. Do you understand? And then hybridization.
Yes.
The hybrids. Okay. Those ones, the exchange of genes take place within species. Like the grafting. You cut that one too is a deliberate act. You want your plant to be like your neighbors, You cut the buds and then fix it, isn't it?
Yeah.
But that cannot happen between maybe mango tree and guava tree.
No.
It has to be guava to guava, isn't it?
Yes.
Okay. So now you know. But even that is exchange of genes. They take place, and before you finally get what you want, like it takes maybe many years. Sometimes you will see some maize colored. Those colored maize, they are not really Gmos. It's that hybridization within species or what. So it gives so it takes so many years for you to have what you want. So, but now in science, based on the understanding of that DNA was discovered in 1953 by Watson and Crick, two scientists. Then later, they didn't really know the innermost detail of the DNA until a lady, Rosalind Franklin, who through her research work of crystallography, taking photos and what, that's how the details of the DNA were actually discovered. That genes are inside, this is air, and this is this one. So based on that understanding, scientists now discovered that you can actually manipulate, the genes. You can actually, because the DNA structure, the content is the same, either in plants or animals. So what we're doing is based on what is already there in nature. So all you're doing is, when they understood that DNA in human, what is the same cell and all those things. So you can now pick, they understood that they can cross that barrier that actually existed, because hybrids can only give you yield. They cannot prevent insects from ravaging your crop and all those things. So but that barrier crossing, I can pick a gene from another source, either from a bacillus, a soil bacterium, what is actually the insect resistant gene is taken from a soil bacterium. That soil bacterium, when it undergoes what will I say, maybe some kind of hardship or what, stress condition, it forms there are things that it forms spores, and those spores, there is something there in it that is that affects insects, something like that. So it's the gene that codes for that is being picked and incorporated into our grains. That's the maize, either maize or cotton or beans or what. So when it gets into the cell of that, it gets manifested and it behaves like it has this anti-insecticidal effect. So you know that they don't even have to eat it. That smell, I mean,
it repels them.
Yeah, it repels them. So that is this thing, and that thing works only in the farm. Its work is just there in the farm to stop the insects from coming into it and then destroying it and what. So you are now crossing. Do you understand? Crossing the barrier based on the understanding of that DNA. So it's science. You're deliberately doing it to save the humankind, to make more food, to make alleviate the sufferings of farmers and what. The breeders have been working with farmers and they see how you put in so much, you plant, and the insects will come. I tell you, these beans, that maruca, the insect that destroys the beans, it can cause 90% loss to a farmer. And that is his only source of livelihood. You can imagine. Some of them are not able to take their children to school. Most times, farmers' children don't go to school. My father was a farmer, so he could hardly. We did primary school years. When it came to secondary school, my father said he will not be able to, because of by the time the next farming season is there, sometimes no food, So my father, in the village, we were only farming maybe to eat and sell maybe 2-3 modus out and all those things. So my secondary school was actually sponsored by my state government, Adamawa state government. So I went to a federal school. And so you can see the plight of the farmer. So now, how do I improve that? That is what the breeders have been worried about. What value will I add? How will I, improve the livelihood of the farmer? What kind of... So they had to think out of the box. And that's, is the advanced science that could break that barrier. The advanced science. The early science, like the hybridization, conventional breeding, could not solve that problem. It can only give you yield. Hybrids can only give you yield, but not to break that barrier of insect resistance.
Okay. Well,
so it's a natural process. I'm bringing that gene from an organism that has cell, and I'm putting it in another organism. That's the plant's host cell. So it's coming to meet the same kind of environment. Like us human beings, sometimes we have problems in our bodies. Some parts, like the insulin, it was the insulin that, the lack of insulin that brings about diabetes and all those things. Insulin used to be harvested from pancreas of pigs to give to humans. Yes. So, it's there. And then, so these things have been... So that's to save human beings, to save lives, to make people to live longer.
Okay.
So you can actually do that.
Now, the next question that I have is quite an interesting one. And, cowpea and maize, has been approved, for genetic modification. Should we expect same for other staple foods like rice and the rest?
Yes, of course. You should expect more crops. We have crops in the pipeline. We have nitrogen use efficient rice being developed by the National Cereals Research Institute in collaboration with the African Agricultural Technology Foundation, Kenya, and other international partners and national partners. Then we also have VICA Plus project. It's cassava, VICA Plus. VICA is virus-resistant cassava. cassava that is resistant to mosaic virus disease, and then as well we have CSBD, and then we have cassava with nutrients, micronutrients, iron and zinc. So it's both virus resistant, and then it's also nutritionally enhanced with iron and zinc to actually help in curbing malnutrition. You know, the zinc is very, very essential. It's an essential micronutrient. And you know, iron, I don't have to tell you, is actually for blood, of course, to help in, you know, curbing anemia in children, especially. And it also helps the lactating mothers, pregnant women, so that you don't even have to be buying drugs and all those things. Once they eat the cassava, they have access to those micronutrients. So then we have other ones. We have the herbicide tolerant soybeans. It's in our institute. We're doing research on it. It's actually for the soybeans to resist or to tolerate glyphosate when you spray it with glyphosate, of course. And so, because the challenge in soybeans cultivation is weediness, weeds coming out, choking up, because it fixes nitrogen to the soil, and so once you plant it, likelihood of grasses growing, and so that's the main. We actually look at the crops and their challenges. What are those challenges that farmers face on their fields? And so how do we now alleviate, how do we now combat those challenges? So we look for the ones that are, you know, because you have to rank them, but which one is more prevalent and which one is more devastating. So you start with that before you go down. It's little by little. Or then we have also the Africa Biofortified Sorghum, also being worked upon by the Institute for Agricultural Research, IR Zaria. Is also for nutritional enhancement, high levels of vitamin A and zinc as well. Since we have cassava in the southern part, zinc, it's sorghum in the northern part, because it's our main staple in the north. Of course, tubers are more in for the southern distinct. You know that in Nigeria, most of our, you know, the staples that we have, carbohydrate-based cereals. We feed more on carbohydrate. Okay, less of protein, because protein is very expensive. So you find out that you know, consumption, high consumption of that carbohydrate gives us a lot of problems and what, like some of these things like arthritis and what, they all result from too much carbohydrate. And so most of the children, you know, they end up with stunted growth. They end up with you know, the tummy will be big because of lack of protein. So most of the parents cannot afford egg, putting egg in their diets, giving them meat, fish. They're all very, and that is why beans, of course, the beans that have been modified. Yes, so we grew up eating beans in the soup. I used to hate it, but actually didn't know. So we had to just we didn't know that. You know, our parents, they were scientists without even knowing.
Their own way.
So there were so many things that they were doing. They would just do it, but they didn't know that, you know, they were doing the right thing. But at least now our knowledge, with more advanced knowledge, we all know what we should eat and what. But then, even if they knew, you know, they didn't. Even if they knew, they didn't have money, you know, the resources to get those things. Egg is not, you know, in fact, sometimes in those days, they didn't even want us to be eating the egg. They saw egg as something very special, very. So most times children are wasted, they're stunted, they have, you know, protruded beriberi, kwashoko, and what, and most of them they die. We lose 1,000 children every day to malnutrition. So it's like one of the ways. How do we combat this malnutrition? Through diets. So if you improve your cereal, your maize, you make it have vitamin A, iron, and zinc. Or like in sorghum, a sorghum has some nutrients in them, but those nutrients are not made available. They are not bioavailable. So the best is to open up a pathway, maybe add an enzyme that will actually, degrade those anti-nutritional factors in the maize and release the protein in sorghum, so that when you eat it, you have access to protein and all those. And if you have those micronutrients, vitamin A, iron, and zinc, you're fine. The child will grow up well without going for meat, without going for egg and what. And zinc is very, very important, especially in keeping you away. It adds to your immune system, builds your immune system, keeps you away from contacting COVID. Yes.
Okay.
Yes, zinc. Zinc. It takes part, I think, in 200 biochemical reactions in the body. Zinc is involved. So zinc is very, very important. In fact, I think people are even advised to take zinc. If you can take zinc daily, one every day, you are less likely to contact COVID.
Okay. Now, from your explanation, we all know that research is quite a tedious task.
It's very tedious
and requires large funding. So in terms of funding, where are we, for genetically modified foods?
Yeah, in terms of funding, it's really difficult. We get funds from the government. I work with National Biotechnology Development Agency, and our main mandate is actually to promote, to coordinate, to carry out research and development in the area of biotechnology, and then also create awareness. We're under the Federal Ministry of Science and Technology. That's my program. OFAP is actually a project, So most times we get funds from the government, but most times you don't get it at the time you need. You don't get so much, so the government needs to do more, and then putting in infrastructure. Light is a major problem. We need light, electricity. We can't do without electricity. For you to do a DNA work, and then the facilities, so much is actually needed. So if we can have more funding for R&D, I think Nigeria will not have any problem. Invest more. We need investment in this area too. And then the infrastructure that we need, the electricity, it's very, very critical components. We need that 24 hours electricity in our laboratories for us to function maximally. And I tell you, if Nigeria invests in biotechnology, biotechnology has it all, not just in the area of agriculture, in the area of health. All the vaccines, they're all biotech products. Vaccine development, and the environment, in the area of environmental restoration, making our environment pollution free, going into the renewables, the renewable energy, the bioethanol, the biodiesel, the works, to reduce emission. We can do away with the fossil fuel, but we have to build capacity, that human capacity. We have to have funds for R&D. And I tell you, Nigeria will go places. That is just, you've hit, the nail on the, head. R&D, research and development funds. That is all that we need to make us go places, achieve food security, environmental sustainability, and then industrialization. We need that. Once we have, because biotech is used in the 4 different sectors of the economy. It's very important. We have to go renewable, seriously. So we get, most times, we get funds from outside, from donors, then get a matching fund. But once we get funds from the donors, getting matching fund from the government side has been challenging.
All right, is there any legal suits involving GMOs in Nigeria like we hear in other countries?
Yeah, we had one. We had one, but we won.
Okay.
Yes.
Great news.
Yes. Yes.
Okay. All right. So, how, for the sake of consumers who still find it difficult to accept the GMOs, how will they be able to differentiate GMOs from non-GMOs?
I think there will be labeling. We have labeling.
Okay.
Okay. Now, let's talk about the impact of GMOs on the environment.
The impact is quite good, beneficial impacts. That's carbon emission. This greenhouse gas emission is one of the impacts. It's like removing, because reducing these farm inputs, fertilizer application, reduction in pesticide use, actually relieves the environment, of this carbon print, and we're reducing all those things. And so the impact is quite much. And then the yield that farmers usually 37% increase in yield. So sometimes if you do it well, it could go up to 50%. And then no tillage, especially in the area of the herbicide tolerant soybeans, because if you farm it, you spray, the weeds go down and support your crop, and then they trap the nutrients because you're not tilling the soil. Soil tillage, exposes the soil to erosion and all those things, and the nutrients will leach out. So it prevents leaching of nutrients, support, and they serve as supports to your plant, and your plants will have more vigor and then produce more, and you have more yield, and there's carbon sequestration. So ozone layer will not be affected. So these are it's like removing maybe 16 billion cars off the road, because the cars, they use petrol, and petrol of course adds to those exhausts, okay. So it's like the impact of biotech, of course, GMOs is quite high.
Okay.
These are just few amongst the many.
Okay. Now, in terms of acceptance, we all know that Nigerians, we have this attitude, of accepting things that we are not used to. For instance, the COVID-19 vaccine. A lot of us are saying, no, I'm not going to take the vaccines because of, some myths and all of that. In terms of acceptance of GMOs, how would you rate that?
It's a difficult question. In terms of what's happening now, in terms of cultivation, farmers' demand or people's demand for seeds, I can rate it 80%.
Oh, wow.
Oh, that's high.
That's quite good.
Yeah.
Okay.
We're now waiting for when we begin to have our beans in the market, in stores and what, consumer acceptance. Maybe 50-50 for now. With time.
All right, now with everything you've said, this GMO crops is actually a game changer for farmers,
for sure,
and for Nigeria.
For sure.
But then, are there any further developments that can be expected in this area?
Industrialization, yeah, is a game changer. We can export. So, and when we export, foreign will earn foreign exchange. Naira will, be valued higher. Yeah, of course, because most times when we export, our crops, our greens, our commodities are, being rejected. The beans was rejected in UK, and I think another crop was rejected recently in US, because most times they complain about the standards. Our standards are not, high enough. And this incessant spray of
insecticides.
yes, insecticides, the residual effect. Yeah, so it's one of those things. But since the technology reduction brings about reduction in farm inputs and all those things, of course, the standards will be high. It will break that barrier of international trade that Nigeria has. Okay. Because if a GM, most of the data I've talked to you about, before Nigeria even approves, the international community also has to look at that data you have generated from your distance. So it's like it harmonizes, it unifies, so that when that crop comes out and they say this is this coming to US, the standard will be high, of course. Right. It improves the quality of grain, also improves the quality of the seeds. So the consumers also, they're getting a more qualitative either commodity or worse. So that's the advantages actually are high in terms of exports and worse, and in terms of value addition to what the consumer is getting and what the farmer is getting and all those.
Well, thank you so much, Dr. Rose, for coming on the show. We hope to visit your office.
Please come and visit our farm. We have the beans now, and we also have the cotton. You will be excited when you see it.
Thank you. We're going to pay a visit soon. Yeah. Well, we've been speaking to Dr. Rose Gidado and on genetically modified foods. Thank you so much for coming on the show. I hope to have you next time.
Thank you so much. Nice being here, and thanks for inviting me.